Hello. Now, at the beginning of this here lecture, I'm showing you again something that we've done last time. So square root and irrational equations themselves. Now, why am I showing you this? Because now we're going to continue on into the next set of numbers, and it is going to be the complex set of numbers. Now, why do we need complex set, or how does it appear? Now, there is an issue with this here definition. And the issue is that we're going to look at the square root of a positive number x is positive number square root of x, where square root of x squared equals to x. Now, in mathematics, what happens from time to time is that, or not just in mathematics, also in physics and chemistry, is that you're going to have a situation like this, so that, for example, number squared equals to something negative. Let's go simple enough and say it's -1. Now, I've said that square has to be positive number. This is what I've written here. Now, in this here situation, it is a negative number. Now, for a long time in mathematics, it was considered that this is not possible because we looked at things really one-dimensionally. When the electricity was discovered, when we started to delve into the science deeper and we started to finding out all the new possibilities and all the new ideas, we learned that the definition that we used, for example, for the square root itself wasn't good enough, because things like that have started to appear more often, and we needed to deal with them because we saw that things work with that, but we didn't know how or why. So we needed to expand what we've known. So we needed to move on from real numbers into a whole new set of numbers, whole new set of ideas. Basically, we went from one dimension into 2 dimensions or even more. More about dimensions further down in this lesson. So, what happens now is this. I'm going to still try to apply the definition of square root and how it works. So I have to find a number which, when we square it, we get -1. Okay. So if I go like further, like this, I have to look at it. So what happens is square and root are going to cancel each other out, and we are going to left with what is inside. So this means that -1 should be also inside. So let's look at it like this. So square root of -1 squared is equal to -1. This is true. Yeah, this is true. So this means that the number we are going to get for the x, so basically this is the x equals to square root of -1. Now this also is not applicable to the original definition where it says the square root is positive number. We got the square root. First of all, yeah, it is a positive number, but inside of the root itself isn't positive number, it is negative. So this whole thing falls apart for this here situation. Now don't worry, what we've learned here is applicable in real spectrum. So for real numbers, everything works. We still use these conditions, still applicable there, nothing changes, but we are now expanding into 2 dimensions in something more, something further down the line, something imaginary, so to say. So first things first, considering this here, I have to now define whole new idea. Now what I'm going to define is the following, and I'm going to say that we are going to work with so-called imaginary unit. I'm going to write this down. What is going to be the imaginary unit and its definition? So imaginary unit is usually written down as number I. This is its term, and the value of I is going to be square root of -1. So I have redefined the x into the I. So I is equal to square root of -1. Now I'm going to also do something here, and let's say if I square it, so this is its definition, this is the original definition of the imaginary unit. Watch out, it's a unit like meters or feet or something like that. So it is a unit. It more says it defines something as imaginary. So if I square I equals to -1 square root of minus 1, what we're going to get is that I squared is equal to square root of minus 1 squared. Applying the definition of a square root, if I square it, is going to give us that I squared is equal to minus 1. So this is another form of imaginary unit. It's going to be important in a couple of minutes of this lesson, further down in this lesson. Now, this opens a whole new set of values that we work with, or set of numbers that we can work with. So this means the following. Let me show you a couple of examples. Now what we can work with is a whole new set of numbers. We are now working with a whole new set of numbers. For example, 3 minus I, or 5 plus 3 square root of 2 times I. I've complicated things a lot. Doesn't matter. Or 5i, or 10, etc., etc. So there is a whole set of numbers. Now, some of them are familiar to you. I would say, for example, number 10. Now, number 10, why is it a complex number? Or complex is part of the complex set. We use it, it's a natural number. We used it before without any issues. It's a real number, nothing specific about it. Well, the things are that I can redefine it as 10 plus 0i. 0 times I is 0, so we don't have it. 10 stays, and it is definitely going to be the real part of it. For example, 5i is the simplest version of the number that we definitely can say it's complex or imaginary, because it consists of I, but it doesn't consist of anything real. Now, think about how I'm saying things here, because I'm now going to define the complex numbers themselves. So let's do that, and then we're going to hopefully have everything in place considering the complex set. So complex numbers are defined as following. We usually use letter Z, and we say that Z is equal to A plus BI. This is the definition of a complex number, where both A and B can be any real number. So 3 is A, 3 times square root of 2 is B, etc. Now, what is important in all of this is the following. A is going to be the real part of the complex number. 10 is real number. 10 plus 0i, this is still real. So real part of the complex number Z is defined as A. In the meantime, we also have imaginary part. Imaginary unit tells us what is imaginary in all of this. So, for example, in this here sense, where 5 plus 3 times square root of 2 times I, this whole thing is B, and it is going to be the imaginary part. Watch out, I'm not using I. I just tells us what is imaginary. So imaginary part of number Z is going to be defined as B without I. I is the unit, like meters, like yards, etc., which only tells us what this number represents. For example, 10 yards represents 10 yards in all of the sense. So B represents the amount of imaginary things we have in all of this imaginary quotes. So let's look at a couple of examples of what is real and imaginary in a complex number. Let's start with example A. Z is equal to 3 minus 5i. Real part of number Z is number 3. Imaginary part of number Z is going to be minus 5 with the sign, so minus 5. I tells us that minus 5 is imaginary part. Now watch out, I cannot combine 3 and minus 5. I cannot subtract them. No, because 3 is a real guy, minus 5 is imaginary guy. guy. So these are completely different units, so to say. One is the real one, the other is imaginary one. Let's look at the B example. W is equal to minus 4 plus 9i. Real part of the W number is going to be minus 4. Imaginary part of the W number is going to be 9. I tells us that 9 is imaginary part. Of course, it's a plus, but I don't have to write the plus itself. Let's look at one more example with the Q number. Q is going to be 6i. Now, what it looks here is that, like, we don't have anything real. Doesn't matter. The real part of the Q then is 0, because we don't have it. Meantime, imaginary part of the Q number is going to be 6, or what is with the I, not I itself. So if you look at imaginary parts of the complex numbers, I've never written down the I. So these are a couple of simple examples. What would I encourage you to do is go through these examples of numbers that I've written down and write down their real and imaginary parts. Look at here. Now this might be a little bit confusing. What is here imaginary part? Well, minus 1 times I. You can rewrite it down like this, minus 1 times I. So now hopefully you see what is the imaginary part of the number 3 minus I. Now, considering the complex numbers, now we introduced a whole new set of numbers. There is all new things going on here, but what we can also do is we have to see and check how the operations work, basic mathematical operations now work for this whole new set. Now, we have 4 basic operations. Let's start with the first, addition. Let's start with that and show you an example. Addition is simple enough. Let's look at 2 complex numbers that are added to one another, or sum of 2 complex numbers. So I'm going to write it down with the brackets so that you know that we're working with the complex numbers. So 8 plus 3i is going to be one of them, added to or with 6 minus 2i. Here we go. Now, here's the addition between them. Now, of course, you can rewrite it down without using the brackets. So let's do it. 8 plus 3i plus 6 minus 2i. Now, who or what can we add actually in all of this? Going back to the definition, what we can add are reals with reals, imaginary with imaginary, guys. So what is the real here? Real is 8, real is 6, 8 plus 6 is 14. Imaginary is 3i, or 3, and minus 2. 3 minus 2 is going to be 1, so plus I. And we got a solution. This is how we do the addition. We add real with real, we add imaginary with imaginary. Let's continue on with subtraction. Let's go with that. Now, considering subtraction, similar situation, similar principle, real with real, imaginary with imaginary. So let's check it out. So 5 minus 6i, let's say it's the one of the complex numbers. Let's subtract it with 3 plus 11i. Of course, we can now rewrite it without using the bracket. Now watch out. Unlike with addition, when you use the subtraction and the bracket, the sign of or subtraction changes the sign of the numbers, both of them. So the first part stays the same. It's 5 minus 6i without the bracket. While now it's going to be minus 3 minus 11i. Watch out for that. Now, what I'm going to do, I'm going to subtract 5 with 3 because they are both real. So 5 minus 3 is equal to 2. Imaginary with imaginary, minus 6 minus 11 is minus 17i. And we are left with, or we got as a result, again, complex number. So we started with complex numbers, we either added them up or subtract them, and we got as a result again a complex number. Now things get a little bit more complicated with the following two operations. Let's start with the third one. This is going to be multiplication. Now for multiplication, I'm going to give you two examples, so just to make sure that everything sets as it should. So the first one is going to be 1 plus 3i times 6 minus i. Of course, I don't have to write down the multiplication sign between them, because well, they are going to be multiplied with one another. Watch out now. And this is something that I've noticed with many of the students in general, is that they don't know how to multiply. Now we multiply the simplest principle with the simplest principle we can, and that is multiply everything with everything. Now what I like to add in all of this is who I'm actually multiplying with who. 1 with 6, 1 with minus I, 3i with 6, and 3i with minus I. So multiply everything with that. I'm actually drawing everything here so I know what I'm going to do. So let's start. 1 times 6 is 6. 1 times minus I is minus I. We continue on. Plus 3i times 6, which is going to give us 18i. And 3i minus I is going to be minus 3i squared, because I and I multiply each other, so they're going to give us I squared. Now, here is where things got a little bit weird, is because now suddenly we don't just work with real numbers, imaginary numbers, or real part, imaginary part, we also work with I squared. Now, don't worry about it, because we defined what is I squared. We said that I squared is equal to minus 1. I wrote it here. So instead of I squared, what I can do now is rewrite it down as minus 1. And what we get is that the imaginary number somehow becomes real. And this is the important step. So I'm going to write this down. I'm not going to even multiply everything yet. So I'm going to write down here, or add, subtract, nothing. So 6 minus I plus 18i, and minus 3 times minus 1. So minus 3 times minus 1, which is going to give us then plus 3. Now we can go back to addition or subtraction, whichever we want to do, and add them up or subtract them. So what we have is, what is real? 6 is real, and minus 3 times minus 1 is real. So minus 3 times minus 1 is going to be plus 3. So 6 plus 3 is going to be 9. Imaginary is going to be minus 1 plus 18 is going to be plus 17i. And we are done. If you need to, go through this one more time in the video. You can pause it, you can go back, don't worry. Let me show you another example of this so we know what's going on. So I'm going to give you now example of minus 7 plus 2i multiplied by 4 plus 5i. So this is the form now. Again, everything with everything. Okay, everything with everything. So minus 7 times 4 is minus 28. Minus 7 times 5i is going to be minus 35i. 2i times 4 is going to be plus 8i. And 2i plus 5i, 2i times 5i is going to give us plus 10. So 2 times 5 is 10, and I times I is I squared. Again, we got I squared. Do not worry about it. I squared is equal to minus 1. Now, of course, you don't want to go every step, every time from scratch. You can already add things up. For example, you can add to minus 35i 8i because they are both imaginary. So I'm going to copy minus 28. Meantime, minus 35i plus 8i is going to be minus 27i, and plus 10 times minus 1. 10 times minus 1 is minus 10. Minus 28 is minus 38 minus 27i. And we've solved the multiplication. So this is the third one. Let's continue on with the last operation, and that is division as a fourth one. And it is most complicated one. The idea is as following. Let me show you an example. So 2 plus 3i is divided by 1 minus 4i. Now the issue arises, how am I going to divide them? What is the division in all this? It's complicated enough. I don't even know how to divide it immediately, but what we do know is we know how to add, subtract, and multiply. So if I multiply things here, I might be able to solve it. Now the following is what we have to do. First of all, I appears in denominator. Now what is I? I is square root of minus 1. So inside of the denominator appears something that is irrational. We don't want to divide things with something that is irrational. It is complicated enough, and we want to get rid of it. So I want to somehow in denominator get I squared, and then apply that it is minus 1. So I got rid of the root, and I'm using now, and I got rid of the I in denominator. Numerator, whatever happens, happens. Now there is a principle that we can use, and it is the following. If I can manage to get a plus b times a minus b in denominator, it is going to lead us to a squared plus, minus b squared. So it is going to lead us to this, a squared minus b squared. Now, why is this important? Because in that case, I will have the following. A squared is going to be 1 squared minus 4 times I, which is going to b squared. So 4i squared, I got I squared. So this is the principle that I'm going to use to get rid of the I in denominator. Now what I have to do to get it. So somehow I, at the moment, have the right bracket. I need the left one. I need a plus. If I have a minus, I need a plus. If I have a plus here, I also need the minus then. So what I do is multiply everything with another fraction so that it is 1 plus 4i here. Now, if I'm dividing this bracket 1 plus 4y, I also want to multiply with 1 plus 4y. Why? Because I can immediately, what happens here? If I cancel these two guys out, I'm left with just number 1. And 1 doesn't change anything. It stays the same. Now, I've done the opposite. I've added things, so the results will stay the same. But now what happens is this. 1 minus 4i is going to be multiplied by 1 plus 4i. In the meantime, 2 plus 3i is going to be multiplied with 1 plus 4i. Okay, so it's going to be multiplied like this. We multiply each individually. And one thing, please watch out this. Never, ever, 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 ever cancel things out in denominator with the numerator. Do not ever cancel one I with the I. Never, because that's not possible. That's just not possible. Please learn that, and it is important for the mathematics in general. Please. Why I'm telling you this? Because I've known that I remember it happened to you also numerous times. So don't do it. Think of them as their own identities separated with a line. which means the division. You're actually not dividing yet, so don't do it. Instead of it, we multiply each part individually, alone, using the multiplication method that I've shown you in the task before. Now, for the denominator part, I don't have to use the multiplication like I did before because I've used the formula, which leads me to 1 squared minus 4i everything squared. So this whole part is going to be squared. For numerator, unlucky enough, we have to go through the multiplication process. So it's going to be 2 times 1 is 2, plus 2 times 4i is 8i, 3i times 1 is plus 3i, and 3i times 4i is going to be plus 12i squared. I squared appeared here, we are going to get rid of it. I squared is going to appear here, we are going to get rid of it. Let's start with denominator. 1 squared is 1, minus square of 4 is 16, square of I squared, I to the power of 2 or I squared is going to be minus 1. So times minus 1. In the meantime, we have 2 plus 8i plus 3i is altogether 11i, and 12 times minus 1 is minus 12. Let's continue on. 1 times minus 16 is going to be 1 plus 16. So it's going to be 1 plus 16. I'm actually going to write it down. In the meantime, 2 minus 12 is going to be minus 10 plus 11i. And the last step is to actually add 16 and 1. So it's 17. And up we have minus 10 plus 11i. And now we are done. If we want to actually write it down as a complex number, I'm actually now going to divide both minus 10 and 11. And I'm going to get the following. Minus 10 over 17 plus 11 over 17, what? I. And real part is minus 10 over 17. Imaginary part is going to be 11 over 17. So this is the division. Watch out, it uses everything that we've learned or gone through with addition, subtraction, and multiplication. It uses those principles. And this is important step. If you have to, go back, go through it one more time, or how many times you have to, in order to remember this. This is important step. And last thing, considering the complex number, is we can also put them, so to say, into a specific plane, and we can show them. We can visualize them. So, small title is complex plane. Let me rewrite down the definition of a complex number. Now, complex number consists of two parts, real and imaginary. It means it works in 2 dimensions. One is going to be real dimension, another is going to be imaginary dimension. So what do? We use similar system to coordinate system. Now, unlike the coordinate system where this would be the x-axis and this would be the y-axis, these axes are going to be called real and imaginary axis, which means that the real part of the number is going to be, or A, is going to be on the real axis. Imaginary is going to be on the imaginary axis. Now, of course, you have to point out 0, 1, and 1. Now, watch out. I'm here using the 1. I'm not using the I or 2i. I'm using 2 or 2, 3, and 3, etc. Why? Because imaginary is still so-called normal number, a real number. The I just tells us that it is on imaginary part of the spectrum of the complex number. Going back to the definition, real and imaginary. Going back to this here part. Now let's go through a couple of examples and put those numbers into the complex plane and and it shouldn't be that hard. It's as simple as using the coordinate system. Now, please, whenever I ask, for example, when I'm going to assess your complex plane part, I need to see that we're working in the complex plane. This means that we have to point out the real and imaginary axis, and of course, then put numbers precisely where they should be. So, A, example. A is equal to 3 plus I. 3 plus I. So 3 is the real. So this is the 3. This is the real part. I is on the complex. There is how many i's? Just one of them. So we are here. So if I want to connect 1 with 3 or 3 with 1, this is going to be A. A is 3 plus 1. So A is here in the complex plane. Let's look at the B. B is equal to minus 2 plus 3i. Minus 2 plus 3i. So minus 2 is the real guy. Minus 1, minus 2. 3 is the imaginary part. 3 is here. Let's connect them. And here is B. Minus 2 plus 3i. I hope you understand how we're doing. So reals are on the real. Imaginaries are without I, of course. It just tells us what it is. Are on the imaginary plane. Let's continue on with C number. C is equal to 5i. So 5i means we're working only with the imaginary part. What is with its real part? Real part is 0. It doesn't exist. So 0 is here on the real. Imaginary is meantime 3, 4, 5. Here is the 5. And here is going to be C equals to 5i. Let's look at the D example, where D is going to be minus 4. Now, minus 4 is a real number. It exists on real axis. There is nothing imaginary considering here. Imaginary part is 0, so I only have to point out the real part. So minus 2, minus 3, minus 4, and here is D minus 4. Let's go on. E, let's show one more. E is equal to, I apologize. E is equal to 1 over 2 plus minus, let's go 1 over 2 minus 2i. So 1 over 2 minus 2i. Sorry for this. I am coming up with the numbers for the examples themselves. So what happens here is 1 over 2 is the real guy. 1 over 2 or 1/2 is between 0 and 1. So 1 over 2 is here. 2 minus 2i, this is now the whole thing that I'm working with. So minus 1, minus 2 is here. 1 over 2, and here is E number. 1 over 2 minus 2i. I apologize for this one more time. Etc, etc. I'm going to give you a couple of more examples for practice so you can go through it. And of course, I'm going to assess all of this before the next lesson. See ya.